Hello, welcome to lesson 2.7 day 1 parent functions and transformations. So we've already kind of laid the groundwork for these transformations, so hopefully that will make this section a lot easier since we've already done some of this stuff. So we've got family of graphs, which is a group of graphs that displays one or more similar characteristics, like a family. They kind of, most of the time, look alike, kind of have the same or similar characteristics. A parent graph is kind of like what you start with in a sense. So it is the graph of what's called a parent function. And it's the simplest of the graphs in the family. So it's our original before we've done any kind of transforming or anything like that to create other members. So let's go ahead and take a look at some of the different types of parent functions. We have what's called the constant, where it's just a number, and we know just a number is going to form a graph that would look like that. So what is its domain? Well, its domain from left to right is negative infinity to positive infinity. Its range is whatever a is, whatever the number is. So for example, this looks like it could be at 4, so it would be a range of just 4, that number. Linear, well, that should hopefully kind of ring a bell for you. Linear is a line. So I'm going to go ahead and just draw all my x and y axes in purple so then you can see that my line right there, and that would be domain of negative infinity to positive infinity going left to right, and going up and down for range would also be negative infinity to positive infinity. Now let's take a look at some new ones maybe for you. Absolute value. So absolute value is going to look like a V. V for value. And notice that we are from left to right, still negative infinity to positive infinity. But when we look up and down, we don't start until 0. So that's our starting point. Remember, we use a bracket for that. 0 to positive infinity and beyond. Next is going to be a quadratic, and you may have heard of this, and you may even recognize its graph. You're going to definitely know it after our lessons here, but it's a U shape. Quadratic. See the U there? Quadratic. And I know you kind of want to think quad is 4, but quadratic is going to be our x squared graph. Okay. Now let's take a look from left to right, negative infinity, positive infinity, and range. Again, we're not starting until 0. So we're going to include 0 and go all the way to positive infinity for the up and down the range. The last one is going to be square root. And a square root is going to kind of look like, I don't know what that is. I don't know how to describe that. Like a little curve. There we go. So we have not starting until 0 and then going on to positive infinity. So this one's 0 to positive infinity. And then look up and down. Again, we're not starting until 0, and then we're going up all the way to positive infinity. All right, let's take a look at the next page. So some parent functions here, we're going to first identify what type they are, and then we're going to write their domain and range. So pretty much what we did on that last page, just identifying now. Well, this one's a V, and I know that's absolute value. Absolute value. And for this one, we have negative infinity to infinity for the domain, because we've got the left side going on forever and the right side going on forever. All right, now let's look at our range. It looks like we're starting here at 0. That's our lowest point, 0, and then we're going to infinity, positive infinity. Okay, next, identify that parent function. Hopefully you're thinking quadratic. Okay, next, it is going left and right from negative infinity to positive infinity. And for the range, starting at 0 for our lowest point, our highest point on forever. So it should be 0 to positive infinity. Try that last one on your own if you need to. Look back at the previous page and check when you're ready. All right, hopefully you put linear, or we could also, it's also known as identity, but negative infinity to positive infinity for both domain and range for that linear graph. All right, now remember transformation rules. I know it's been just a little while, but they'll come back to you, and I promise that all that previous work will help you when we get to these next sections here. So remember that shifts up and down go behind our function. When it's on the inside, it's opposite thinking, and that's going to move us left or right. Negatives are reflections, and big numbers or fractions out front are going to be stretches and compressions. Okay, so again, opposite thinking when we're on the inside, normal thinking when we're on the outside. Outside is vertical, and inside is horizontal. So let's go ahead and take a look at page 18. So all this says up here is basically all of that stuff we just reviewed in the chart, but kind of with it, where it would be placed in the function, what would be happening. So if there was a negative out front, that's what would be happening. If there's a number out front, that's what would be happening. If there's a negative inside, that's what would happen. Number inside, that's what's happening. Number inside the parentheses there, that's what's happening. Number behind, that's what's happening. And then remember, anything on the outside is vertical, anything on the inside, horizontal. Let's go ahead and try some. So remember how a function notation works. Basically, all we're doing is taking whatever number they're telling us and plugging it in. So if it's f of a diamond, we plug the diamond into the absolute value. If it's f of heart, then we plug the heart into the absolute value. If it's f of 5, we plug that into the absolute value, and etc. If there's more than one thing, plug it into that absolute value. Now, some of these aren't always going to be absolute value, so we might have to use parentheses or make sure that it gets under the radical. That would be considered plugging it in for that function. So all of these are going to have the same transformation. So you're going to see me just write the transformation once, but that applies to all three of these, no matter what their function is. It's all going to be transformed the same way. And in this case, when it's a -7 on the inside, that's going to be left and right. We do opposite thinking, so it's not going to be left like we think, it's going to be right 7. So I'm going to go ahead and put right 7. And again, it's going to transfer all the way to these three. They're all moving right 7. Let's take a look at the first one. We want to have x squared. So what are we plugging in? Well, x minus 7, we're plugging it in for x. So we want to have a set of parentheses, and we're going to replace the x. Let's make sure we've got our square, don't forget that. Replace the x with an x minus 7. Well, that's it. This is f of x minus 7, and it's equaling that. All right, let's try it again for absolute value. So it's absolute value. What are we replacing the x with? X minus 7. All right, what about square root? Well, square root, again, we're replacing the x with x minus 7. You can use parentheses under there if you want to, but it makes sure it's all underneath that radical. Let's try it again with one where it's behind the function. So that means we're going to write the entire function. Nothing's going to actually be plugged in for x. And then behind it, we're going to put the plus 9. Okay, so it's going to be a function of x. So just x is replacing our f of x here because we want to use This is our function. Now behind it, we put the plus 9. All right, next one would be absolute value of x, and then the plus 9. Next one, x squared, then the plus 9. So what's happening here when we have something behind? That's vertical movement, right? And what do you think a plus 9 is? How is that going to move it vertically? Up, you got it, up 9. And again, all these would be moving up 9. This is just going to be the shape. Remember how we talked about parent functions and what they would look like? So if we just add a plus 9 behind their function, it would move all of those up 9, no matter what the function is. Let's try two things this time. We are going to plug in an x minus 1 and behind it a minus 3. So remember, replace the x with what's in the parentheses, x minus 1. This is absolute value, so we need to have our absolute value bars on the outside there. Now, what goes behind it? Yep, a minus 3. Okay, what are we replacing the x with x minus 1? What can we not forget? The squared. So it's x minus 1 squared, and then behind it, minus 3. Okay, plug in underneath the radical the x minus 1. And then behind the radical, make sure it's not underneath it, a minus 3. All right, I want you to try some of these on your own. And then I'm going to go through some of the answers so that you can check and see what's happening. Before you continue on your own, let's write what happened here. Minus 1 is left or right, and it's opposite thinking, so right 1. And the minus 3 behind it, vertical movement, down 3. And again, all of these would be right 1 and down 3 since they all are going to be having this transformation applied to their parent function. All right, so go ahead and try this section, and on the next page, a couple of these. And then I'm going to go through them here in just a second. So pause, try some, and then check your answers when you're ready. All right, pause the video now if you need to check these and see how you did. All right, and pause the video for 16 through 24 if you're ready to check those. So it's the same thing that you're doing on all of these. You're just determining, well, are you plugging something in? So that goes on the inside of your absolute value symbols or parentheses or under the radical. And then everything else just goes on the outside. We've done some of that similar before. Also check your transformations if you got those correct. So pause, check. All right, our last two sections. What we're going to do is determine what happened, and then we're going to apply that to our parent function. So it looks like we moved down 5. So we're going to take our x squared, and how would we move it down? Well, vertical movement's on the outside, and down would be a minus 5 behind it. And you can look back to those previous charts to help you. Looks like we're moving right 2. Again, comparing our parent function to our son or daughter function, I guess. And it looks like right 2 is in the inside because it's horizontal movement, and it would be opposite thinking. So not a plus, but a minus 2. Try those last two on your own and check when you're ready. All right, see how you did with 3 and 4. Pause if you need some more time to check. All right, our last section, absolute value. Same thing we did before, only this time we're stretching it vertically. So let's put vertical stretch, and we kind of look at the slope. It looks like it's up 2 over 1, so it's a stretch by 2. So that means we want that 2 out front of our absolute value. This one is a compression vertically. It's pressing it down, and it looks like our slope is up 1 over 3, so that's a 1/3 compression. and that goes out front of our absolute value. Try those last two.